Hello, my dear viewers. I welcome you once again to another lesson under the topic acids, bases, and indicators. We continue to look at the different aspects of acids, bases, and indicators. Your presenter again, Namiiro and Ms. Mugoya from Trinity College, Nabinga. The concept of strength of acids mainly looks at strong and weak acids. Acids are grouped into either being weak or strong. This entirely depends on the ease of the acid to release hydrogen ions. When do we say that an acid is strong? An acid is strong if it is completely ionized in aqueous solution. What do I mean by ionizing? Ionizing is that process of releasing ions in solution. So when the acid completely releases its hydrogen ions and then the radical ions in solution, we say it is completely ionized. Strong acids are usually also strong electrolytes. Now, all mineral acids are strong acids. I hope you remember what mineral acids are. So, examples of strong acids. Do you remember any examples of strong acids? The mineral acids, they are sulfuric acid, nitric acid, hydrochloric acid. What do we mean by ionizing? This you should see in an equation. Like sulfuric acid there ionizes to give us hydrogen ions and sulfate ions. Complete ionization is shown by that arrow, a complete arrow, one arrow facing forward. Okay, it is double-headed. That shows us that our sulfuric acid has completely ionized or is completely ionized in solution. So in the above equation, we are seeing that sulfuric acid has completely ionized in water, forming three kinds of particles. Which are they? The hydrogen ions, the sulfate ions, and the water molecules, which are there. They are present because we are dissolving the acid in water. Hydrochloric acid also ionizes to give us hydrogen ions and chloride ions. So in the solution, you will have hydrogen ions, chloride ions, and water molecules. Strong acids, we say, react more vigorously with metals than weak acids. Why do we say they react more vigorously? Remember, we said that these ones are completely ionized. It means we have a large quantity or a large amount of hydrogen ions or a big number, okay, whichever that you want to refer to it. So the more the hydrogen ions, the more vigorously the acid will react with metals. So the hydrogen gas bubbles here are produced rapidly because we have more hydrogen ions present. Then we have weak acids. Weak acids are partially ionized in water. Remember, what did I talk about ionizing? Releasing of hydrogen ions. They partly release the hydrogen ions. The remaining molecules will remain unchanged as acids. These ones are also said to be weak electrolytes. Their reactions are usually reversible. The reversible reaction is normally shown by a double arrow. Actually, the arrow is half. There are two half arrows, one facing at the front, one facing behind. Okay, so this is shown in an equation. As you can see, the equation for phosphoric acid that I've written for you there. You have phosphoric acid ionizing to give you hydrogen ions and phosphate ions. Other examples of weak acids, we have ethanoic acid, we have carbonic acid, and phosphoric acid. So weak acids will react slowly with metals than strong acids to produce hydrogen gas slowly. Why? Because of the incomplete ionization, we have fewer hydrogen ions. Next, we look at, or we want to compare the concept of strength of an acid and concentration. When we are talking about concentration, we are looking at the amount of solute of the acid dissolved in 1 liter of a solution. Whereas for strength, we look at how many ions are or can be disassociated from the acid. Strength looks at how many ions are produced. How many ions are produced from the acid. The more ions that are produced, the stronger the acid. In fact, the more hydrogen ions, to be more specific, we look at how many hydrogen ions are produced from the acid. The more hydrogen ions produced, the stronger the acid. Then we also say that for concentration, we can change it. We could either dilute the acid by adding more solvent, that is water, or we can concentrate the acid by adding more of the solute. For strength, we cannot do that. We can neither, add hydrogen ions or remove them. An acid will either be naturally strong or naturally weak. What do I mean here? If I'm having 10 moles per decimeter cubed of ethanoic acid solution, we say is a concentrated solution of a weak acid because ethanoic acid is a weak acid. The 10 moles per decimeter cubed, moles are a quantity. It is a unit of measurement of quantity of substances that we use in chemistry. And you will study more about moles in the subsequent topics. So if I have 0.1 moles per decimeter cubed of ethanoic acid solution, we say this is a dilute solution of a weak acid. I hope we know what a decimeter cubed is equivalent to. It is equivalent to a liter. So if I have 0.1 moles in a liter of ethanoic acid, that solution is dilute because I have a small amount of the solute. If I have 10 moles per decimeter cubed of hydrochloric acid solution, I would say now that one is a concentrated solution of a strong acid because we said that our hydrochloric acid is a strong acid. Okay? So if on the other hand now I have 0.1 moles per decimeter cubed of hydrochloric acid solution, then I would say now this one is a dilute solution of a strong acid. Okay, I hope you have got that one very well. We continue to look at properties of acids and we'll start by looking at the physical properties of acids. Physical properties mainly are those things that we can use to distinguish a substance using our senses, or what we can see, what we can touch, what we can feel, what we can taste if the substance is edible. So for acids, we say the first, acids have a sour sharp taste. If you have tasted lemons, you know what I'm talking about. So lemons are sour because there is citric acid. Acids also change the colors of indicators. The common indicators that we have are litmus, methyl orange, and phenolphthalein indicator. Acids will turn litmus from blue to red, methyl orange from orange to red, and phenolphthalein indicator colorless. Chemical properties. The chemical properties of any substance are usually the reactions of that substance. So we start by looking at The reaction of acids with metals. Acids react with metals to produce hydrogen gas. The gas is tested with a burning splint which shows hydrogen gas present when it burns with a pop sound. E.g., we would have sodium reacting with hydrochloric acid to form sodium chloride and hydrogen. Magnesium reacts with hydrochloric acid to form magnesium chloride and hydrogen. Zinc would react with hydrochloric acid to form zinc chloride and hydrogen. So you would notice that in the reaction of an acid with a metal, we form a salt and hydrogen gas. I hope you are not thinking that it is only hydrochloric acid that reacts with metals. Even other acids react with metals. How do we set up the apparatus? We have a beaker in which we put our acid solution, then we put particles of the metal inside the solution. The moment these two are added together, we shall see bubbles of a gas that we test with a burning splint, as you can see in that illustration. 2. Acids react with carbonates and hydrogen carbonates. This reaction between acids and carbonates or hydrogen carbonates, we look at it when the acid is dilute. Okay? So acids react as acids if and only if they are dilute. What does this reaction form? The reaction leads to formation of a salt, carbon dioxide gas, and water. To test for carbon dioxide gas, we use lime water. And as the carbon dioxide gas is bubbled through lime water, we form a white precipitate. So an example there, we have copper 2 carbonate reacts with hydrochloric acid to give you copper 2 chloride plus carbon dioxide and water. If I have sodium hydrogen carbonate, whether solid or aqueous, its reaction with hydrochloric acid leads to formation of sodium chloride, carbon dioxide, and water. How do we set up the apparatus? The apparatus is set up like that. You would use tubes, 2 boiling tubes, test tubes. In one test tube, you put the carbonate and the acid, and the other you put lime water. Then you have your delivery tube to deliver the produced carbon dioxide. Please take note that the colors that you see in this diagram are not the absolute, the last ones. Actually, they don't show a good representation of the carbonate in question. Calcium carbonate is usually, well, actually it is white. Sulfuric acid is a colorless liquid, and lime water is a colorless liquid. Those colors are just to help you to understand that we have the acid as a liquid and the carbonate as a solid. So in conclusion, today we have looked at the concept of strength of an acid. We have looked at the properties of acids, that is, the physical properties and the chemical properties, which are basically the reactions. So for us, we have concluded that an acid will react as an acid, that is with metals and carbonates, when it is dilute. So until we meet again next time, you can be visiting our link www.tricona.sc.ug/e-library for more information, for more lessons, and for you to get a deeper insight of different aspects of the subject chemistry. Until we meet again next time, stay home, stay safe, bye.